212 days after the failure of the first test launch in April 2023, SpaceX performed the second test flight of the Starship spacecraft. Meanwhile, a device to redirect flames was installed. Ship 25 and Booster 9 underwent cold testing in May. On November 15th, Ship 25 was connected to B9 for launch, and the FAA granted permission. The flight was delayed a day to replace a part on November 16th. SpaceX addressed issues from the first flight, including separation stages, while engines are still hot, and switching to electronic control for Super Heavy Raptor engines. The platform and ground system were reinforced to prevent pad foundation problems from recurring. Still, they could not succeed in what they aimed for. The biggest Starship rocket blasted midair. Why did this happen? Is it another failure? What really happened on November 18th during IFT-2 that led to this? In the morning, with only 1 minute left before the rocket took off, the engines were cooled, and the rocket was filled with about 10 million pounds of fuel. It was getting ready to start its engines. When the countdown clock reached 40 seconds, there was a planned pause for a few minutes. During this time, the teams checked all the systems and made sure no boats were in the launch area. Although they had about 15 minutes to wait, they only waited for about 2 minutes before continuing the countdown. When the clock reached close to 5 seconds, water started spraying from a cooled plate in preparation for liftoff. At T-0, the big Starship and Super Heavy booster began their flight at around 7 a.m. local Texas time from SpaceX's Starbase in Boca Chica. All 33 engines lit up together to lift this 52,000-ton vehicle into the sky. The Starship is an extremely big rocket, almost 400 feet tall. It's the largest and most powerful rocket ever made. You can see it from far away when it's on the launch pad. Only 4 seconds after the launch, the Starship was in the air. After 10 seconds, it was completely off the launch pad. This was faster than the first test flight on purpose. The rocket started going faster, and all 33 engines were working well, as shown in the data at the bottom. After 42 seconds, the cameras showed the bottom of the booster, and all 33 engines were still working. In the last test flight, some engines were already not working by this time. In April, the first launch had problems. The rocket was destroyed about 4 minutes into flight using a self-destruct command. One reason for the failure was that the two stages of the rocket didn't separate like they were supposed to. To prevent this problem in the second flight, SpaceX tried a new method called hot staging. Hot staging means that the second part of the rocket starts its engines while the first part's engines are still running. This keeps both parts experiencing upward G-forces, which helps to keep the fuel at the bottom of the tanks. Even though this idea isn't new and has been used in the past, like in NASA's Gemini programs and Russia's Soyuz rocket, SpaceX used it to solve the issue they had in the last launch. By 1 minute and 12 seconds after liftoff, they announced that Starship had reached max Q, which is when the rocket experiences the most mechanical stress. At that moment, the Starship was flying at about 15,000 kilometers per hour and close to 15 kilometers high. These numbers kept going up for the next minute or so until the most important part of the mission, the separation of the Starship stages. It happened as planned, about 2 minutes and 41 seconds after the rocket took off. It seemed to go smoothly. If you look at the pictures of the rocket's engine, you'll see that at the bottom there are 3 engines that reduce power to half at a certain point. Shortly after, the people in charge of the mission said that these engines had stopped working. The bright light at the bottom of the Super Heavy rocket became faint. Then, only 3 other engines in the upper part of the rocket started working to create enough force to separate the different parts of the rocket. The bottom part flipped over, turned on some engines again to come back, but not all of them started working. Engine issues worsened, causing the rocket to explode 2 minutes and 48 seconds into the launch. Initial separation of the rocket's bottom part appeared successful, but the Super Heavy rocket started flipping during descent. The camera captured the flipping section heading toward the landing area, revealing the onset of a significant problem. At 3 minutes and 15 seconds after the launch, you could see some of the engines on the bottom part trying to start for the return burn. There was a small explosion and liquid started leaking. Finally, at 3 minutes and 20 seconds, the whole bottom part of the rocket broke apart unexpectedly. The rocket might have had problems that made it fail early, This could have led the engineers on the ground to intentionally destroy it because of issues with the fuel. At 4 minutes into the launch, you could just about see the upper part of the Starship. At that time, the vehicle was going really fast, over 7,500 kilometers per hour, and it was 117 kilometers off the ground. The data also showed that all 6 Raptor engines were working fine. For the next 3 minutes, the upper stage kept speeding up and getting closer to its destination in space. But around 8 minutes into the launch, the vehicle became hard to see. If you look really closely at 8 minutes and 8 seconds, there were big disturbances in the air, suggesting there might have been an explosion. So here's what happened in the most important parts. First, the engine shut down in groups of 5 on the outer rings, and the core engine slowed down to 50%. The fuel kept flowing, creating a more visible trail. Gravity caused the speed to drop, leading to a hot staging. The 3 vacuum engines started first, making a big show. The booster's speed dropped quickly because the engine pressure pushed against the top, showing that it was slowing down. Then the booster started turning on all engines again, and most of them started working. Meanwhile, the Starship kept going on its own path, but we're focusing on what happened with the booster. After stage separation, the second part, called Starship, floated for more than 5 minutes until SpaceX lost communication. The engines turned off at 8 minutes and 4 seconds, and the flight ended at 8 minutes and 7 seconds. At the same time, all 6 engines stopped, and the speed of the vehicle stopped going up. The plan was for the Starship's engines to turn off at 8 minutes and 33 seconds. The ground engineers were waiting to get a signal back, but after some comments they said, "We lost the data from the second stage. We heard that it was on the right path, but we haven't got any more data." So it seems like we lost the second stage. Later they found out the second stage exploded because of the flight termination system. It's clear that the Starship seemed to fly well for some minutes. They heard a call out about the right path as it tried to get to the right orbit at a speed of about 27,000 kilometers per hour. Just before reaching the right speed, there was a puff of gas. The engines turned off, and the telemetry stopped, suggesting the spacecraft likely ended, maybe because of a problem with the second stage. Around 7 minutes into the flight, there was a problem on the spacecraft. A small amount of gas came out, which could mean something went wrong with the oxygen. The data we looked at showed a drop in oxygen levels right before this happened. It could be because of a leak or a problem with the engine, which caused a big failure. A minute later, there was a small puff, followed by a bigger cloud of gas. People are guessing that a safety system might have turned off the flight because it sensed a lack of oxygen. The pieces of the spacecraft, which are now in the Gulf of Mexico, are expected to have traveled far into the Atlantic. Weather radar from NOAA, National Oceanic and Atmospheric Administration, showed a long trail of debris, and there are unconfirmed reports of debris falling over Puerto Rico. The debris getting smaller as it goes further is because the spacecraft was going faster and parts burned up. During a live webcast on November 18th, John Innsbrucker, who works at SpaceX, said the safety system activated later than usual. The recent data about the rocket's path was not good. It seemed like the rocket might crash near the Turks and Caicos Islands. According to the analysis of the astrophysicist YouTuber Scott Manley, the rocket explosion might be because of a problem with releasing oxygen. The rocket didn't work because it ran out of liquid oxygen too quickly, and the second stage lost gas. There were delays in testing because of problems with the launch pad and water system, but those were fixed quickly. Now they're focusing on making the big booster safer to prevent explosions when it separates. The main engine probably shut down because of problems delivering fuel, and there are worries about the engine being exposed and pipes getting damaged during sudden stops. The booster exploded, but we're not sure why. SpaceX didn't say if they used the emergency system, maybe because the booster stayed on its planned path. Engine failures happened when the rocket was spinning, but we don't know if there's a connection between the spinning and the order of failures. We need more information, like details about the emergency system and why the explosion happened suddenly. The recent Starship test faced uncertainties due to potential issues like off-course trajectory, engine problems, or errors. It marked a setback for SpaceX in achieving successful rocket stage separation, although details on the specific cause are still awaited. SpaceX tried to make a big rocket, the Super Heavy. land gently in the Gulf of Mexico after launching it into the sky. They wanted to see how it comes back to Earth and land. They hoped to keep communication with the rocket when it was about 150 miles high. Unfortunately, that didn't happen. But even though the rocket blew up at the end, the launch was considered successful. SpaceX learned valuable insights about the rocket's performance, including stage separation and thrust control, advancing towards the goal of using Starship for human transport and supporting NASA's Artemis program. Despite an explosion, SpaceX remains dedicated to enhancing Starship through continuous testing. The recent test flight on November the 18th marked an improvement, with the rocket reaching an altitude of 148 kilometers, surpassing the 100-kilometer space boundary, indicating success despite challenges. Quote, "Honestly, it's an incredibly successful day despite the rapid unscheduled disassembly of both the Super Heavy booster and the ship," mentioned SpaceX Quality Engineering Manager Kate Tice. "That's fantastic. We gathered a wealth of data, and it will significantly contribute to our improvements for the next flight," unquote. So what are your thoughts on the challenges faced? Do you believe the advancements are worth the setbacks? Share your insights in the comments below. Don't forget to hit the like button, subscribe for more space updates, and ring the notification bell to stay tuned. Thanks for watching.